Okie dokie. So we'll get started on question number 7. And this one, if we read the question, it says for the following problem, okay, these are application problems. Question number 7 says 2 people enter a whispering gallery and want to know where to stand so that they can hear the other person whisper. Do y'all know what a whisper gallery is? Yeah, so 2 people could stand like on opposite ends of the room, and the way that the room is designed, you can hear somebody talking across the room because of the way that the sound travels through the room. It's kind of a cool thing. So this says that 2 people enter, they want to know where they should stand. The gallery is 100 feet wide, and the vertical distance from their head to the peak of the ceiling is 30 feet. So the shape of this room is that like it's a regular room up until I guess technically their head. And let's keep in mind that like they're assuming these people are exactly the same height and all that. So obviously it's not a 100% real world problem. So it's saying that at their head, like I guess it's like if they were standing right in the middle, the top of the gallery, it's 30 feet above their head. So I'm going to start labeling some of this stuff. Oh. Yes, this is what the other sheet of paper is. You have no room to do it on there. So I'm more concerned looking at the actual ellipse part of this. So the top half of this, where is my pen? Okay, so the top half of this, if we cut it right there, this creates an ellipse, the top piece. So that's kind of what I'm going to look at. I guess maybe it would be like a semicircle. It'd be a semi-ellipse. I've never thought of that. So we've got this semi-ellipse. I'm not good at drawing that. But there's our semi-ellipse, and it says that this height, let me move this. So all this corresponds with this top half. So this is 30 feet. And we know that it's 100 feet wide. So from here to here, this is 100 feet wide. But when we talk about an ellipse, so if we imagine this to be our center, we need to know, let's see, it wants to know where they stand. And it doesn't say in the problem, it's assuming that you know that these people need to stand at the 2 focus points. So we really just need to know C. So that's what we're doing. Find C. That's our goal, to find C. So to find C, what 2 values do we need to know? Huh? A and B. So if we need to know A and B, here's one of them. This can help us find the other, which would be this distance. So what's this distance? 50. What is the formula for an ellipse to find C? What do we hear it is? What do we think it is? Nope. For an ellipse, you add in the equation. So the formula to find C, it's opposite that. You subtract. Yeah, so here's the good news. If you forgot and you did plus, what would happen is that your focus points would end up being outside of the ellipse. So you would figure out that, ooh, I did something wrong. So you have to subtract. Which one of these is A though for an ellipse? Yep, the bigger number.
Or is that just it?
Yeah, because it's C squared is equal to A squared minus B squared. So C is equal to the square root. Do what? Because it's the distance from the center to the one of the vertices. So remember that A and B are kind of like the radius in each direction. So for this one, I would go up 30 and down 30 if it was a true ellipse, and out 50 in both directions. For an ellipse, so this is a review. For an ellipse, the bigger number is always A. And you can tell by the formula, because if the bigger number could be B, what would you end up with in the square root? A negative number, and that's not going to work. So the bigger number is always A for an ellipse. That is not the case for a hyperbola, so keep that in mind. So an ellipse, the bigger number has to be A. And so I end up with C is equal to the square root of 50 squared minus 30 squared. Okay.
Oh.
So you got 2,500 minus what? 900. It has to be a smaller number. So let's just look at 25 minus 9. What is that? Yeah.
You could just have done 50 minus 30. So it's 40.
Do you understand why they could ask you this question and expect you to be able to do it without a calculator? Because this is like a 3, 4, 5 right triangle right here. So you could technically do this without a calculator. So there's two ways you could look at this for describing where these people need to stand. And it wasn't specific because it just said, where do these people need to stand? It doesn't say how far from the center or how far from the wall. So they need to stand, if that is your center, they need to stand right there and right there. So not quite to the wall. So there's two ways we can describe this answer. They can either be 10 feet from the wall or 40 feet from the center. Bless you.
C is the focus, right?
Mm-hmm. Okay, so they need to stand 10 feet from the wall or 40 feet from the center of the room. And definitely, this is a question you could do without a calculator. All right, the next one. A hyperbolic cooling tower is 100 meters wide at the base. The most narrow section of the tower is 100 meters above the ground and 40 meters wide. How wide is the cooling tower at its highest point, which is 160 meters above the ground? I don't think that they will give you one of these on the test because you definitely need a calculator. This is very similar to the question that was on the homework, question 22, but let's go through it. So for this one, we need to label our picture. And I'm going to put, we know that for a hyperbola, we have a center. And we go some value left and right, some value up and down, and it creates this box. Hold on, I gotta move my face. It creates this box. Let me make this a different color. Kind of makes this box that we use to make our asymptotes. We're going to pretend like that's a really nice looking X. And so when we make our hyperbola, we need to know a couple values. We need to know A, we need to know B. We need to create an equation. So there's a couple of things that we need to try and figure out. A, B, X, Y, because we have to find certain points on this hyperbola. So what we're going to do is look at what we know. So the cooling tower is 100 meters wide at the base. And so that's cool. I know that it's 100 meters wide at the base. That distance is 100. I also know that 100 meters above the ground, that's where the shortest piece is. Sorry, the skinniest piece. This is 100 feet off the ground, that this distance is 40. The highest point is 160 meters above the ground, so this distance would be 60.
A equals 80.
No, so this corresponds with this piece right here, if we put the center right in the middle. So if the whole width is 40, what is that A value?
20.
20. So A is 20.
I thought A was the bigger number. Is it because this one's vertical?
It's because this is a hyperbola. So we would attach right here. And my hyperbola would look like this. So there's my hyperbola. I know that this is 20. I also know, I know a point on the hyperbola. I know this point right here. Let me make it a different color. I know this point right here because I know that to get to this point, if I'm calling this my center, and if the whole thing is 100, well, half of it would be 50. So I could go over 50 and then down 100 to get to this point right here. So I know a point. I can use that. I don't know what B is. I don't know how wide it actually is. Like there's nothing in the problem that actually gives me a B value. So I have to first solve for B. So that's my first step. Solve to find B. Okay, that's my first step. So I'm going to label the things that I know in my, over here. Where's my, there we go. I know A is 20. I'm going to plug that in. I don't know what B is. I know that this coordinate right there is 50 minus 100. So 50 and then negative 100. I don't know B. And my A value is 20. So I'm going to use that using my equation of a hyperbola to figure out my b value. So I'm going to plug all of this stuff in. This is a hyperbola that opens left and right. So it's a horizontal hyperbola with x squared listed first. So it's going to have this basic formula, x minus h squared minus y. I'm thinking and writing at the same time. Y minus k squared always equals 1. So over a squared and b squared. I also know what h and k are. H equals 0, k equals 0. My center is at 0, 0. That's where I'm putting I'm calling that 0, 0. I should have mentioned that. I'm calling h and k 0, 0. So I'm going to plug in the things that I know. If h and k are 0 and 0, then I'm plugging in my x value, which is 50. So this becomes 50 squared over a squared, which is 20 squared, minus my y value that's squared. What happens when you square a negative number? Yeah, so does it matter if it's negative 100 or positive 100? No. So I'm just going to put 100. My b value, I don't know it. B squared equals 1. So yes, you could be asked, like, how would you set up to solve for b? But you couldn't actually solve it without using a calculator. From here, if I want to get b by itself, so here's the thing, b is in the bottom of a denominator. I need to get this fraction by itself. So I'm going to bring it to the other side by subtracting. But there's a 1 here. So I'm going to bring the 1 over to this side. So I'm going to blow your minds with algebra. At this point, I'm going to switch places with both of these. Nothing, I'm not doing anything to these. From here, I need to get b squared isolated, and so the only way to do that is to like multiply it over here, but I have stuff over here. So I'm going to switch places again. I'm going to take all of this and my denominator, so this is another move that I'm going to do. Take all of those things and they are going to switch places. So I get b squared is equal to 100 squared divided by 50 squared divided by 20 squared minus 1. Now to get b all by itself, how do I undo something that's squared? Yeah, so I'm going to get rid of that. This is squared and square root all of this stuff. Desmos is your friend and will allow you to pretty much type all of that stuff in exactly the way that you see it. Hold on, let me see.
Why do we, how do,
I'm going to type it in exactly the way I see it. I need a square root. The square root you got to find down here. Square root 100 squared divided by 50 squared divided by 20 squared minus 1. I know it looks pretty ugly, right? But that is our answer. So we get 43.644. Is that what's up here? I can't see it. It's too little. Yeah? Okay, so we end up with B equals 43.644. So now I know what B equals. I'm going to go put this over here. Let me get rid of this screen. All right, I know what B equals now. Now that I know what B equals, I can find what it's actually asking me. The question that it's actually asking me is how wide is the cooling tower at its highest point? Well, I know that the highest point is at 160. Now that I know my B value,
Value.
it's how far up and down you're going in the formula. It's this right here.
Right down.
Because we don't know that this height or this the top or the bottom of the tower is actually at that B value that creates this rectangle. We don't know that. Like you could have made the tower starting here. We don't know where it actually starts in this hyperbolic shape. So we had to figure out our B value. Now that we know it, we can actually use the other coordinate. Let me do this in green. So now we're going to use a different coordinate. We don't know the X value, which would be the width. But to get to this point up here, it's some value of X. And then 160 for my Y value. So to solve, to figure out my X, I'm going to use all the same values, but I'm going to use a different X and a different Y because I'm using a different coordinate. I want to find where I am up here. So I'm going to plug into the same equation. It's still going to be 50 squared. For this one, it's going to be different X value because I don't know the X value. I'm going to solve for X. I don't know the X value this time, but I know that A is 20 and my Y value is going to be 160. My B value is 43.644 because I just solved for it. So now I want to find the X value. So I'm going to have to do more math magic. It's going to be very similar to the steps that I did over here. But I want to isolate X. So to isolate X, I'm going to move this whole fraction. And it's negative on this side. So when I bring it over, it's going to become positive. So I get X squared over 20 squared equals 1 minus X squared. Oh, hold on. I'm subtracting the wrong thing. Oops. Plus 160 squared over 43.644 squared. All right. So I moved this whole fraction to the other side and I added. I still don't have X by itself. I'm dividing by 20 squared. So when I bring it over, I'm going to have to multiply by 20 squared. So I'm going to bring this over and I'm going to multiply everything by 20 squared. So I get X squared is equal to 20 squared times 1 plus 160 squared over 43.644 squared. How do I get rid of something that's squared? How do I unsquare something? Square root. So I'm going to square root this whole side. So it's very similar. Why don't we take into account plus and minus the square root? Yes, so would a negative distance really make sense? No. So yes, technically, if this was naked math, we would have to do plus and minus the square root, but it doesn't make sense here because we're doing real world stuff. So I'm going to get Desmos out because Desmos is very handy. So I'm going to make a new one. And this is the square root of, and I type everything in at one time. So we've got 20 squared times 1 plus my fraction, 160 squared divided by 43.644 squared. Okay, what did we get? Why did I get a different value when I worked?
75.999.
Oh, I know why. I know why. I know why. I know why. I know what I did wrong. If this is our center, if this is at 0, how far up are we going? Are we going the full 160? We're just going 60. So I need to erase the 1 everywhere. So we're not going. That's an easy fix. There we go. I took off all of the 1s. So erase all the 1s. I'm just going a value of 60 to get to the top of the tower. I'm smarter than that. I'm just going a value of 60. So I'm going to go, that's also nice with Desmos is I can fix it pretty easy. I'm just going to go up here and delete that. So now what do I get? I can't see it. It's too little. So tell me what it is. Okay. Yeah. 33.999999 stuff, right? So we could say that the width is about 34. Would you agree? Because we're kind of estimating here. It's about 34, but 34 is the distance from the center to here. So how wide would the whole, because it says, how wide is the cooling tower at its highest point? It wants the entire distance. So we're going to have to take that and multiply by 2.
What, bro?
Yes.
This is
No, 34 times 2.
why is we doing it times 2?
What's 34 times 2? That you can do in your head.
Why is it times 2?
I can't write and talk. Give me just 1 second. Yes, so remember we're orienting everything from the center. So to get to this point right here, we just went over 20 and then up 60. And so it's only giving us the distance, that X distance. Okay, the cooling tower is about 68 meters wide. So you can use the same super skills to solve question number 22 from your homework. And so you have to do the same thing. You have to first solve for B. And then as soon as you solve for B, then you can plug it in to solve for what it's actually asking you to solve for. And so that's how you would do question number 22. But we still have a little bit more that we're doing in this packet. We're going to do the parabola problem. This one isn't quite as involved. The parabola problem. A flashlight has a parabolic reflector that has a diameter of 52.25 millimeters and a depth of 23.95 millimeters. Where should the bulb be placed so that the flashlight is optimized for a focused beam of light? Okay, well, let's sketch it out. Let me find my pen. We're going to sketch it out. We've got a parabolic shape. So we know a parabolic shape is like this, where we've got a definite ending because a flashlight doesn't like go on forever. The light does, but like the actual shape of your flashlight doesn't, it stops. We want to figure out, let's see, we know the vertex. We're just going to put the vertex at 0, 0. And we're trying to figure out where the bulb should be from the vertex. So when we talk about a parabola, this is going to be, we need to know what this p-value is. That's really what we're solving for, is p. And so for this one, I have my parabola that's faced like this, so should my x be squared or my y be squared? This is the parabola we know and love, and x is always squared. So I'm going to write the formula for a parabola. So we've got x minus h squared is equal to 4p y minus k. Okay, for this one, my x is squared. From here, also, if I'm looking at a p-value, remember that the distance that we're talking about, where should this light bulb be? It's going to be a positive, like it's this far from the vertex. Let's figure out what we do know. Let's see, it has a diameter of 52.25. So that's this. And we also know that there is a depth of 23.95.
What's the bathroom, please?
This is our last example. Can you sit through the example?
Yeah.
So it says, where should the ball be placed? We need to know a couple of things. We know what the center is. We know what H and K are. We need to know a point on this flashlight. So we could figure out a point on this flashlight. What if we use this point right here? If I use this point right here, how would I get there? Wouldn't it be half of 52? Mm-hmm. Well, half of 52 is 26.125. And then actually it would be negative because I'm going in a negative direction. And then 23.95. I made it negative because if I call this 0, 0, I would be going in a negative direction and then a positive direction. I'm going to plug in all the pieces that I know. I know H and K. H is 0. K is 0. X is negative 26.125. K is 23.95. I'm plugging all of those things in to figure out what P is, because P is going to be this distance right here. Because if I called this 0, 0, to get to this point, I would be going a negative X direction. Here? Oh, H, K, Y. Thank you. Not 2 Ks, that's a Y. Thank you. So I'm going to plug in the things that I know. H and K are 0, so when I plug this in, I get my X value, negative 26.125 squared equals 4p, my Y value, 23.95. What's going to happen when you square a positive? Sorry, when you square a negative. So does it really matter if we say that it's negative? Could we have used this point right here? Yep, and it wouldn't matter. So to get P by itself, I need to divide by, I need to take the 4 over and the 23.95. I can do it all in one step. So I get 26.125. It doesn't matter if it's negative, divided by 4 times 23.95 is equal to P. I'm going to use Desmos because it's awesome. And I'm going to type it in just the way that I see it. Again, it makes no difference if I use this point or this point. When we square whatever our x value is, it's going to change it to a positive. So I get 26.125 squared divided by 4 times 23.95.
7.124.
Yep. 7.124. So P.
No, it's supposed to be at 7.1.
So we could say, I mean, this is a real world problem. We could say that P needs to be about 7 millimeters from the vertex. I mean, it's just a little over that. So, sorry, the bulb. The bulb needs to be a little over 7 millimeters from the vertex. Or 7.124 to be exact. We're done with that part, and now we're actually going to go to the top. I'm going to end my video. And y'all are going to do the top for me.